Hello, everyone. Hello. This is Tiger, and today we're just going to talk about some amazing calculation skills. And well, these are definitely going to be useful, um, whatever it's for your exams or like for some competitions, it's always going to be useful. And today I'm just gonna, talk about these techniques and skills for fast calculation. So the first one, and actually the most important one, or the most commonly seen one that I'm going to introduce to you is extracting the common multipliers. So just as written here, if I have A multiplying B and A multiplying C, it would be equivalent to A multiplying the sum of B and C, which means that I am extracting the A from both multiplications between AB and AC, and I'm multiplying the sum of B and C altogether. And how does that work? So probably I can show you some examples. For example, let's do it with some easy numbers. Let's say 2 times 3 adding 2 times 4. And that's going to be equal to 2 times 3 adding 4. Let's see if that's true, all right? So 2 times 3, that's 6. 2 times 4, that's 8. 2 times 3 adding 4, which is 7, is going to be 14. So yes, 6 adding 8 is 14 indeed. And the reason behind is because 2 times 3 can be understood as 3 twos, right? And 2 times 4 can be understood as 4 twos, which means that if I'm adding 3 twos to 4 twos, the total I'm going to get is equal to 3 adding 4, which is 7 twos. So that's the reason why I can sum the 3 and the 4 and multiply that to 2. All right. So let's see how we can make use of this in the calculation questions. And of course, because we are now in year 7, the calculation is slightly getting harder than what you have done in primary school. For example, there's going to be a lot of fractions and a lot of minus numbers, like negative numbers. So you need to reason that, all right? So for the first question, we can see that the fraction 11 and a seventh is occurring 3 times. Oops, sorry. It is occurring 3 times. So it has shown up 3 times in the calculation. However, for the first two, they both have a negative sign in front of it. So how do we get rid of the negative sign? Well, the way we can get rid of the negative sign is to, try to write it out and consider it as the sign of the whole multiplication. For example, minus 11 and a seventh times 5 can be written as minus 5 times 11 and a seventh, right? And minus 4 times minus 11 and a seventh can be written as plus 4 times 11 and a seventh. So I don't actually need the brackets here, all right? I don't actually need the brackets here. I put the brackets around just to show you that we are considering the product and the signs separately, all right? And then finally, we have minus 6 times 11 and a seventh. So that's just minus 6 times 11 and a seventh. Right? So now we can try to remove the brackets. Next step is try to remove the brackets because we don't actually need the brackets, right? So we can try to remove the brackets now. And you can see that now all the 11 and the sevenths, they are positive. Now all of them are positive, which means that I can extract them from the separate multiplications and just write 11 and a 7th right here. And what should I multiply it to? I should multiply it to the sum of all the other multipliers, right? So we have -5, multiplying -5, adding 4, take away 6. So that's going to be the next line of our calculation, okay? And now finally, if you're taking away 11, 5 and 6 makes 11 altogether. So if you're taking away 11 from 4, you're going to get -7, right? So we have 11 and a 7th multiplying -7. And do I want to do that directly? Yeah, of course I can. I can just try to multiply the 7 or the -7 to both the numerator, like both the fractional part and the number part of this mixed number. So we have -77, take away 7/7, which is equal to -78. All right, that's a 7, so -78. And that's going to be the answer to this question. All right, does it make sense to you? Now, let's take a look at another question we can make use of this extracting common multipliers property. So we have 2 to the power 100, adding -2 to the power 100, adding -2 to the power 99. So what's going to be the answer? Oh, I think I might have been hiding one of the options behind. Yes, there's a little 2 right there. Right, so that's the option D, which is 2. Or probably I'm just going to write it here. The option D is 2. All right, such that I can enlarge myself again. All right, so how do we extract the common multipliers here? Well, we know that if I have a power, it means how many times it is multiplying itself, right, for any numbers. So -2 to the power 100 means that -2 is multiplying itself 100 times, where -2 to the power 99 means that it is multiplying itself 99 times. So what is the relationship between 100 times and 99 times? Well, apparently 100 is one more than 99, isn't it? So we can say that -2 to the power 100 is -2 multiplying -2 to the power 99. And we are now adding -2 to the power 99. All right. So what do we have? What we have is going to be extracting the -2 right there, the -2 to the power 99 right there, such that it becomes just one of it as a common multiplier. And what do I multiply to? So first of all, I have got the -2, right? And what about the other one? Well, if there's no coefficient there, it means that it is multiplied by 1, because anything multiplied by 1 is itself, right? So we have adding 1 right there. It means that I am doing, all right, I need to put the brackets around just to make it precise. And well, so the next step is to simplify it. We have -2 to the power 99 multiplying -1. All right. So the next question is, apparently, now we are just going to eliminate options C and D, because -2 to the power of 99 multiplying -1 cannot be -2 or 2, apparently. But is it going to be A or B? In other words, I'm just asking you whether -2 to the power 99 is positive or negative. because we definitely know that -1 is negative, right? And anything multiplying a negative number, if it is positive, so if something positive is multiplying a negative number, it's going to be negative. If something negative is multiplying a negative number, it's going to become positive, right? So is -2 to the power 99 positive or negative? It should be negative, right? It should be negative. Because if I have an even power, for example, like power of 2, power of 4, then it's going to be positive. But if I have an odd power for a negative number, it's going to be negative. Okay? So it means that multiplying -1 is going to become a positive product. And as for the value, we consider it separately from the signs. So the value is just 2 to the power 99 multiplying 1. That's going to be 2 to the power 99. And that's the answer for the second question. Okay? Does it make sense to all of you? All right. So next, let's take a look at the third question, which is to form some integers. All right. So apparently it might sound a little bit weird, but that's what we do. Try to form integers, or like putting parts together such that it becomes easier to calculate. For example, in the first question, well, we can try to observe it first. We can see that 2 of them has a denominator of 3, where the other 2 has a denominator of 6. So if I just try to simplify the signs or the operations first, maybe I will see it more clearly. So first of all, I have -2/3. And then I have 2 minus signs in a row, which means that it's going to turn positive. So I'm adding 4 and a 6. Next, I have a positive and a negative, which makes a negative. 2 different signs makes a negative. So I'm taking away 7 to the power 7 and a 6th. Finally, I'm subtracting 6 and a 3rd. All right. So now if you just try to combine these two with a denominator of 3, you can see that -6 to the power, -6 and a 3rd, take away 2/3, it's going to be -7, right? So these two join together to make -7. And what about the other two? If I am removing 7 and a 6th from 4 and a 6th, what do I get? Well, first of all, the 1/6 should be cancelled out. And then I'm taking 7 away from 4, which means that it is -3. Okay, so combining the two findings, the answer is going to be equal to -10. All right. So that's the answer to the first question. And what about the second one? So it looks a little bit complicated, isn't it? 8 dividing -1 and 1/3 multiplying -12.5 multiplying -4 over 5. So what do we do? Well, first of all, we can just try to get rid of the sign, right? So for the multiplication and division, well, if I have an even number of minus signs, it's going to be positive. If I have an odd number of minus signs there, it's going to be negative, right? I mean, multiplying or dividing in a row, which is exactly what question 2 is doing right there. Yeah. So if I'm just trying to simplify question 2, first of all, we can see that there are 3 minus signs, which are dividing each other or multiplying each other in a row, which means that the whole answer, like the answer for this second question should be negative. Let's put a negative there. And then I can just forget about the sign and carry on with the calculations. So we have 8 there. Well, dividing 1 1/3 would be equivalent to multiplying 3/4, right? Because 1 1/3 can be written as 4/3. So dividing it means that I need to topple it around, taking the reciprocal of it and multiplying it, right? And then next I am multiplying 12.5 and finally multiplying 4/5. All right. So what do we do here? Well, now you can see that if you multiply 4 and 12.5, you're going to get 50 if you multiply them together, right? So simply, you can just write the next line as minus 8 times 3/4 multiplying 50 over 5. So that's how I can find the integer there by 12.5 and 4. Such that now it becomes pretty easy for us to calculate it. All I have remaining to do is to simplify these fractions when I'm trying to multiply it, right? So 50 and 5, they have a common factor, 5, which means that if you divide the common factor, it's going to become 10 and 1. And 8 and 4, they have a common factor of 2. So it becomes 1 and, no, they have a common factor of 4. Of course, 2 as well, but like, if you just divide it by 4, it will be more convenient. So now the denominator has all been cancelled out. The only thing that is left is what we have in the numerator, 2 times 3 times 10. So that's going to be equal to minus 2 times 3 times 10, which is 60. All right, so the answer is minus 60. Does it make sense? All right. So that's the answer to the second question. Now we are moving on to the last 2 questions, which are both making use of the grouping method. Oh, so this time I do need to shrink myself a little bit or put myself somewhere else. Right, I'm just going to put myself here. Okay, so if you can just take a look at this question, try to observe how the signs are changing, all right? So we have 1 adding 2, subtracting 3, subtracting 4, adding 5, adding 6, subtracting 7, subtracting 8, adding 9, and so on. So if you just look at it carefully, how many operations do you think is a pattern? Yeah, that's right. You can say every 4 of them, right? Every 4 of them is a pattern. But then, well, you can try to choose which 4 do you want. Say, for example, there is actually 2 resolutions for this question. The first one is that if you take every 4 terms, starting from the very beginning as a group, then you can see that, well, you can easily see that in each of these groups, the sum is going to be minus 4, right? So basically, I just need to know how many groups are there in the whole sequence, and then I'll be able to calculate it. So we know that the last number in this sequence divisible by 4 is 100, which means that this is going to be the last group, which is also minus 4. And we know that there are 25 groups of 4s within 100. So you can say that it is minus 4 times 25, adding 101, which is equal to minus 100, adding 101. That is 1, right? So that's the first method, but I don't actually like it because I need to do some calculations in that and I need to understand what's going on, right? But then if you are observative enough, there is actually a simpler way of doing it. If you would just start from 2 and take every 4 as a group. You can see that it always goes in a pattern of adding, subtracting, subtracting, adding. And amazingly, each group has a sum of 0. Yeah, that's amazing. And according to the question, the last group should be here because it is following the pattern adding, subtracting, subtracting, adding, and it is also having a sum of 0. So it means that starting from 2, every 4 numbers will cancel out themselves. Every 4 numbers will cancel out themselves. So in the end, I have 1 adding a bunch of zeros. I don't care how many there are, as long as they are all zeros. So the answer is 1. 1 is the only number left. So the answer is 1. Okay. So I hope that you can try to make use of this question or this technique to solve the last question right here. I think that's going to be pretty easy for you now. Just try to observe the patterns and make a choice. Like, how would you group these numbers? This is called the grouping method. Well, this might be slightly less popular, but then always there's a chance to come up, right? So yeah, I just want all of you to be able to master this method because it is super easy. You just need to look at it, observe the sign changes, and you'll be able to get the answer, right? So every 4, starting from 1, can be grouped into a sum of 0. And because we know the last group is adding, subtracting, subtracting, adding as well. So, and of course, the fact that 2016 is divisible by 4, that also helps. But even if you don't want to calculate that, by following the pattern plus, minus, minus, plus, you know that it is a complete group. Totally. Right? So it means that the last group is also going to sum up to 0, which means that everything is summing up to 0 in this sequence. So the final answer is also going to be 0. All right. So the answer is 0. Okay, so that's everything for today. If anyone has got any questions for me, just don't hesitate to send me a message and let me know. I'll try my best to help. All right. Okay, if that's the case, then I'm just going to call it a day. Thank you very much, everyone, and I will see you all tomorrow for the next day 2 practice. All right. See you soon. Bye-bye.